if we actually plug in for an infinite amount of rectangles, we'll get the right answer. Well, how do we do that? How do we plug in infinity? Well, let's go back to our favorite problem, 1 minus x squared. Okay? We're going to 1 minus x squared. That's been our problem we've started with. And we're still going to go from 0 to 1. But we want to find this area beneath it. But this time, we're going to have n partitions, okay? So I'm going to say I equals 1 to n of, and this is going to be the limit as n approaches infinity, because we love limits, of I equals 1 to n. Now, if we have n partitions, what would be the width of each partition? 1 over n. Because it would be b minus a over n. So I'm going to have 1 over n partitions. All right, now, let's do a right-hand Riemann sum here. A right-hand Riemann sum, I'm going to have f of I over n. Are we good with that? Okay, now, also remember that n is a constant. Because we've been having like 10 here, 10 was a constant. We pulled it out and so forth. So n is a constant, so I can actually pull that out. And again, what would f of I over n be? 1 minus I over n squared. Yeah, it's the original equation. I'm trying to find f of I over n. Do you have a question on this? Okay. Okay. Well, this would be 1 over n. I equals 1 over n. Okay. 1 minus I squared over n squared. Are we still good with that? Okay. Now, I'm going to break this up. I'll tell you what, let's get a common denominator and do this. This would be n squared over n squared. Are y'all with me? Okay. So it's going to be 1 over n times the sum of I equals 1 to n of n squared minus I squared over n squared. Hold on, let me think just a second. That, I'll tell you what, I'm not going to do that after all. That's going to make a little more work than what I want. Okay, I'm just going to split it up into two. I think that's, I was looking at it and thought that one way would be easier, but it's not. Okay.
We still supposed to have the distance approaching infinity last time.
Yeah, thank you. All right, n, this would just be n. right here, right? All right. Now, this is going to be the formula itself. N times n plus 1 times n plus 2, no, 2n plus 1 all over, yeah, well, it's going to be n squared times 6.
So it'd be 6n squared.
Yeah, but I'm going to factor out that n squared in just a second anyway. Oh, okay. Let me, I think I got time to do one more step and then we probably won't finish. I'm going to get a common denominator right here. Now, limit as n approaches infinity of 1 over n times, this will be 6n, that's a lot like an m, 6n cubed over 6n squared. All right, now, it's going to be minus, and I'm going to have to do this product right here in 2 steps. So it's going to start off as being n squared plus n times 2n plus 1, right? Which is going to be the limit as n approaches infinity of this will be 6n cubed, all right, minus, all right, n squared times 2n is 2n cubed, all right, plus n squared, plus 2n squared, plus n, and then I'm going to put it over 6n cubed. Okay, I guess all I want you to do for homework is to reduce this down and see if you can come up with what the answer is.
It's fixing to be like the parent formula for all of this.
I don't know.